In today's video, we are going to take a closer look at what we mean when we talk about a magnetic material and also explore the important differences between permanent magnets and induced magnets. One of the things that often causes confusion when discussing magnetism is the fact that not all magnetic materials are actually magnets themselves. A true magnet is any object that actively produces a magnetic field on its own, meaning it has a consistent and detectable region of magnetic influence surrounding it. In contrast, a magnetic material refers to any object that can be affected by a magnetic field and has the potential to become a magnet, but does not necessarily generate a magnetic field by itself. So, when we ask which elements are magnetic, we are usually referring to which elements can behave as magnetic materials, not which ones are already functioning magnets. For example, even though nickel is a well-known magnetic material, not every single piece of nickel will automatically behave like a magnet. The other most common magnetic elements that you should remember are cobalt and iron, both of which also exhibit strong magnetic properties. Additionally, alloys that include these elements, such as steel, are also considered magnetic materials. To help you recall this specific group of magnetic elements, a handy trick is to remember the acronym formed by their first letters, which spells out NCIS: nickel, cobalt, iron, and steel. Now, when we think about typical magnets like the bar magnets used in classrooms or science kits, what we are actually thinking of are permanent magnets. These magnets generate their own magnetic fields constantly and do not require any external magnetic influence to do so. However, there exists another category of magnets, known as induced magnets, or sometimes called temporary magnets. These do not naturally produce a magnetic field, but instead only become magnets when placed in the presence of an existing magnetic field. Induced magnets are formed when a magnetic material that was not originally acting as a magnet, for instance, an ordinary piece of nickel, is placed within the magnetic field of a permanent magnet. This exposure causes the material to temporarily develop its own magnetic field and form distinct poles, typically a north and a south, effectively transforming it into a magnet for the duration of its exposure. This is why we refer to it as an induced magnet. It has been magnetized due to an external influence. A key fact to remember about the interaction between permanent and induced magnets is that the force between them will always be attractive, meaning they will pull toward each other. This is why, in our earlier example, the side of the nickel piece facing the permanent magnet became a north pole and not a south pole. It aligned itself in a way that created attraction rather than repulsion. However, this magnetism does not last forever. Once the induced magnet is removed from the presence of the external magnetic field, it will begin to lose its magnetic properties. The speed at which it loses this magnetism depends on the specific material. Some magnetic materials, like nickel and iron, tend to lose their magnetism very quickly, which is why they are referred to as magnetically soft materials. On the other hand, some materials like steel retain their magnetism much longer after being removed from the magnetic field, and these are called magnetically hard materials. And that brings us to the end of today's lesson. If you found this explanation useful and enjoyable, please give us a like, hit that subscribe button, and we will see you again in the next video with more fascinating insights into the world of science.